Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind adjust the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
I'm Philip Emeagwali. At 10:15 a.m. New York time, Tuesday the 4th of July of 1989, I experimentally discovered how and why parallel processing makes new computers faster and makes new supercomputers fastest. And I invented how and why to use that new supercomputer knowledge to build a new supercomputer that encircled a globe and encircled it in the manner the internet encircled a globe. The reason my experimental discovery made the news headlines was that for the 4 decades onward of 1946, the parallel processing machine was a supercomputer-hopeful that no supercomputer scientist understood what made it super. The new supercomputer, in turn, gave birth to the new field of computational science. And a new supercomputer gives birth to a new computational science. The importance of computational science was underscored in an article that was in the May 8, 1987 issue of the Chronicle of Higher Education, the flagship newspaper that presents news to universities. That article was written by computer and information technology writer Judith Axler-Turner. The article was titled, quote, "Some Hail Computational Science as Biggest Advance Since Newton Galileo," unquote. My 4th of July of 1989 experimental discovery of how and why to use massively parallel processing to solve initial boundary value problems of a new calculus and of the fastest computational physics made the news headlines as the biggest advance in computational science. My world's fastest supercomputer algebraic calculations made the news headlines and entered into the June 20, 1990 issue of the Wall Street Journal. A week later, the computer and information technology writer Judith Axler-Turner wrote in the June 27, 1990 issue of the Chronicle of Higher Education that I, Philip Emeagwali, quote, "took on an enormously difficult problem," unquote. That enormously difficult problem that I solved and that made the news headlines was the toughest problem in extreme scale computational science. Judith Axler-Turner continued in her Chronicle of Higher Education article that Philip Emeagwali, quote, "solved it alone, has won computation's top prize, captured in the past only by seasoned research teams," unquote. My discovery that made the news headlines back in 1989 was the tipping point of the increasing speeds of the supercomputer. That turning point in massively parallel processing supercomputing of the 4th of July of 1989 led to a new computer. I was asked to explain why American children are writing school reports on my early life in Nigeria, Africa, and on my contributions to the development of the fastest supercomputer. Teaching the groundbreaking discovery of any historical scientist is not mandated in US schools. However, it's included in the guidelines known as the Core Knowledge Series. It's included in Social Studies Standard. Each teacher decides how to incorporate stories about scientists into her curriculum. The computer was not invented by super intelligent aliens from the moon that are disguised as humans. Therefore, the fathers of the modern computer should be studied in schools that use computers. Philip Emeagwali is studied in American schools because I experimentally discovered how and why parallel processing across a new internet is faster than computing within any vector processing supercomputer that was the state-of-the-art technology of the 1980s. Ironically, I am mostly studied in schools in the United States, not in my country of birth, Nigeria, Africa. Historically, if a scientist such as Albert Einstein or Thomas Edison or Alexander Graham Bell is studied in American schools, that scientist will later be studied in schools all over the world. But if a scientist is only studied in schools in Nigeria, that scientist will only be studied in schools in Nigeria. My experimental discovery of how and why parallel processing makes computers faster first made the news headlines in 1989 in the United States, and my discovery story spread to American schools and to newspapers in other countries.
Insightful and brilliant lecture.